All right, this is Unit 1, Lesson 4, Arithmetic Sequences and Series. Our lesson essential question is, what is an arithmetic sequence and how do you represent and find its terms and their sums? At the end of this lesson, you'll be able to interpret arithmetic sequences and series. All right, so example number 1 says, understand arithmetic sequences. So is the sequence arithmetic? If so, what is the common difference? What is the next term in the sequence? So I have 3, 8, 13, 18, 23. This is a sequence, a function whose domain is the natural numbers. Create a table that shows the term number or domain and the term or range. So the first term number is 3. It's number 1. The second term number is 2. It's 8. 3, 13, 4, 18, 5, 23, 6 is a question mark because we don't know. The difference between consecutive numbers in the range is 5. So I go from 3 to 8, I add 5. 8 to 13, I add 5. So an arithmetic sequence is a sequence with a constant difference between consecutive terms. This difference is known as the common difference, or D. This sequence is an arithmetic sequence with the common difference D equals 5. The next term in the sequence is 23 plus 5 equals 28. How could you write a formula for finding the next term in the sequence? Okay. So each term can be represented by f of n, where n represents the number of the terms. So for n equals 1, f of 1 equals 3. If n is greater than 1, each term is the sum of the previous term and 5. So f of 2 equals f of 1 plus 5, f of 3 equals f of 2 plus 5, f of n equals f of n minus 1 plus 5. So write a general rule for an arithmetic sequence as a piecewise defined function. So for f of n equals f of 1, n equals 1, and for f of n minus 1, n is greater than 1. This is the recursive definition for an arithmetic sequence. Each term is defined by operations on the previous term. Another way to write a recursive definition is to use subscript notation. So a sub n equals a sub 1, where n equals 1, or a sub n minus 1 plus d, where n is greater than 1. With the notation, the subscript shows the number of the terms. So this is the first term, and this is the whichever term comes next. Okay, minus the previous term. Is the sequence 4, 7, 10, 13, 16 arithmetic? If so, write the recursive definition for the sequence. So a sub 1 equals 4. The common difference D is 3, so this is an arithmetic sequence. Okay, so I add 3 each time. The recursive definition for the sequence is a sub n equals 4 when n equals 1, and a sub n minus 1 plus 3, which is the difference, when n is greater than 1. All right, so let's try it. Are the following sequences arithmetic? If so, what is the recursive definition and what is the next term in the sequence? So I have 25, 20, 15, 10. So each time I'm adding a negative 5. So D equals negative 5. So it is an arithmetic sequence. So I have f sub n equals so for this one, remember, a sub 1 equals 4. So for this one, a sub 1 is going to be 25 when n equals 1, and a sub n minus 1 minus 5, so plus a negative 5, when n is greater than 1. And the next term is 5. Okay. How about for 2, 4, 7, 12, 13? So from 2 to 4, I add 2. From 4 to 7, I add 3. 7 to 5, I add 5. 12, I add 1. So this is not an arithmetic sequence. All right, example 2, translate between recursive and explicit functions. So given the recursive definition, a sub n equals 3, where n equals 1, and a sub n minus 1 plus 0.5 when n is greater than 1, what is the explicit definition for the sequence? An explicit definition, also written as a sub n equals a sub 1 plus d n minus 1, allows you to find any term in the sequence without knowing the previous term. So I use the recursive definition to find a pattern. A sub 1 equals 3. A sub 2 equals 3 plus 0.5. A sub 3 equals a sub 2 plus 0.5, which equals 3 plus 0.5 plus 0.5 equals 3 plus 2 times 0.5. A sub 4 equals a sub 3 plus 0.5. Well, a sub 3 was 3 plus 2 times 0.5 plus 0.5. Well, there's 3 of them now, so 3 plus 3, 0.5. So the first term has 0 common differences added. The second term has 1 common difference added to the first term. The third term has 2 common differences added, and so on. So the explicit definition is a sub n equals 3 plus n minus 1 times 0.5. In general, the explicit definition of an arithmetic sequence is a sub n equals a sub 1 plus d times n minus 1. So given the explicit definition, a sub n equals 16 minus 3 times n minus 1, what is the recursive definition for the arithmetic sequence? The common difference d is negative 3, and a sub 1 equals 16. The recursive definition is a sub n equals 16 when n equals 1, and a sub n minus 1 minus 3 when n is greater than 1. So they took the 16, that was my first number, and the minus 3, that was the second part. All right, so let's try it out. For the recursive definition, a sub n equals 45, n equals 1, and a sub n minus 1 minus 2 when n is greater than 2. What's the explicit definition? So for this, we are going to have 45, because that's what it starts, minus 2, because it's the minus 2 here, times n minus 1. 45 minus 2 times n minus 1. For the explicit definition, a sub n equals 1 plus 7, n minus 1, what's the recursive definition? So for this, a sub n equals 1 when n equals 1, and a sub n minus 1 plus 7 when n is greater than 1. Here I took this first number, that's my first, and then my second number. In this case, it's a plus 7, so that's where I get the plus 7 from. All right, example 3, solve problems with arithmetic sequences. A high school auditorium has 18 seats in the first row and 26 seats in the fifth row. The number of seats in each row forms an arithmetic sequence. What is the explicit definition for its sequence? Okay. So the problem states that a sub 1 equals 18, n equals 5, and a sub 5 equals 26. So I have a sub n equals a sub 1 plus d times n minus 1. Well, a sub 5 is 26 equals 18 plus d times 5 minus 1. Okay, so 18 seats in the first row, 26 seats in the fifth row. That's where that n comes in. Okay. So 26 equals 18 plus 4d. I subtract 18 from both sides. I get 8 equals 4d. I divide both sides by 4, so I get 2 equals d. Each row has 2 more seats than the previous row. The explicit definition is a sub n equals 18 plus 2 times n minus 1. A high school auditorium has 18 seats in the first row and 26 seats in the fifth row. The number of seats in each row forms an arithmetic sequence, which we found in the last portion of this problem. So that was 2. How many seats are in the 12th row? So knowing what our explicit formula is, a sub n equals 18 plus 2 times n minus 1, I want to figure out the 12th row, where n is going to be 12. So a sub 12 equals 18 plus 2 times 12 minus 1. 12 minus 1 is 11, times 2 is 22, plus 18 gives me 40. So the 12th row has 40 seats. All right, so let's try it. Samantha is training for a race. The distances of her training form an arithmetic sequence. She runs 1 mile the first day and 2 miles the 7th day. What is the explicit definition for the sequence? So we know that a sub 1 equals 1 mile, n equals 7, 7th day. A sub 7 equals 2. So I'm going to go ahead and solve. So I have a sub n equals a sub 1 plus v times n minus 1. A sub n, or a sub 7, equals a sub 1 plus v times n minus 1. I'm going to solve for d. So a sub 7 is 2 equals 1 plus v times 7 minus 1. So I have 2 equals 1 plus 6v. All right, I subtract 1 from both sides, so I get 1 equals 60. So d equals 1/6. So my explicit definition is a sub n equals a sub 1 plus 1/6 and minus 1. Okay. So how far does she run on day 19? So again, I take my recursive, my explicit function, I substitute 19 in for it. So a to 19 equals 1 plus 1/6 times 19 minus 1. So a sub 19 equals 1 plus 1/6 times 18. 18 times 1/6, so that's 18 divided by 6, which is 3. So a sub 19 equals 1 plus 3. So a sub 19 equals 4. So she ran 4 miles. All right, example 4. Find the sum of an arithmetic series. What is the sum of the terms in the arithmetic sequence 1, 4, 7, 10, 13? What is a general formula for an arithmetic series? So a finite series is the sum of the terms in a finite sequence. A finite arithmetic series is the sum of the terms in an arithmetic sequence. The sum of n numbers in a sequence, you can use a recursive formula or simply add the terms. So s sub n equals a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus up to a sub n. So in this case, 1, 4, 7, 10, 13 gives me 35. This represents a partial sum of a series because it is the sum of a finite number of terms, n, in the series. To find the sum of a series with many terms, you can use an explicit definition. So to find the explicit definition for the sum, use the commutative property of addition and reverse the order of the terms in the recursive series. Substitute the values from the series. Step 2. Add the two expressions for the series, so you are adding the first term to the last term and the second term to the second to the last term, and so on. So 1 plus 13, so you can see that they're all equal to 14. Simplify. Notice that 14 is the sum of the first and last terms, or a sub 1 plus a sub 5. 2 times s sub 5 equals 5 times 14, or 5 times 1 plus 13 over 2. Writing a general formula, I have s sub n equals n times a sub 1 plus a sub n over 2. So what is the sum of the following arithmetic sequence? 2, 6, 10, 14, 18, 22. My n is 6. There's 6 numbers. 1, 2, 3, 4, 5, 6. Okay. A sub 1 is 2. A sub n is 22. So use the general formula to find the sum. S sub n equals n times a sub 1 plus a sub n over 2. Okay. So 6 times 2 plus 22 over 2 equals 144 over 2, or 72. So the sum of the terms in the sequence is 72. All right, so find the sum of each arithmetic series. For series with 12 terms, a sub 1 equals 3 and a sub 12 equals 25. So S sub n equals 12 times 3 plus 25 divided by 2 equals 12 times 28 divided by 2, which equals 168. So for B, I have 5, 11, 17, 23, 29, 35, and 41. So I have 1, 2, 3, 4, 5, 6, 7 terms. 7 terms. A sub 1 is 5, and a sub 7 equals 41. So S sub n equals 7 times 5 plus 41 divided by 2. 7, 1 is 46 divided by 2, which gives me 161. All right, concept, sigma notation. The sum of n terms of a sequence can be written using sigma notation, which looks like this. Okay? The index I counts through the terms in the partial sum. Here it takes the values from 1 up to n. The last term in the partial series, the value of the ith term is a sub I. You can use the explicit formula for this sequence in place of a sub I. All right, so example 5, use sigma notation. What is the sum from I equals 1 to 9 to I minus 6? Okay, so I find the sum by writing out all the terms in the series. For a sub 1, 2 times 1 minus 6, 2 times 2 minus 6, 2 times 3 minus 6, 2 times 4 minus 6, 2 times 5 minus 6, 2 times 6 minus 6, 7 minus 6, 8 minus 6, 9 minus 6. Okay, and I add all those terms together, which gives me 36. Okay, so this number tells me where to start. This number tells me where my I stops. How can you write the series 2 plus 9 plus 16 plus 79 using sigma notation? What is the sum? Okay. So step 1, solve for n to find the number of terms in the series. So a sub 1 equals 2, d equals 7, a sub n equals 79. Okay. So a sub n equals a sub 1 plus d times n minus 1. Remember, our d was how many we add each time. Okay, so 79, which is a sub n, equals 2 plus 7 times n minus 1. I subtract 2 from both sides to get 77 equals 7 times n minus 1. Divide by 7, which gives me 11, equals n minus 1. Add 1 to both sides, gives me 12. There are 12 terms in the series. I write the explicit formula for the series. A sub n equals 2 plus 7 times n minus 1, which equals 7n minus 5. And then I write using sigma notation. The index I will count from 1 to n equals 12. So I equals 1 to 12, and then 7i minus 5. Okay. To find the sum, I use the formula that I learned, S sub n equals n, a plus 1 plus a plus sub n over 2. So I get 12 times 2 plus 79 divided by 2 equals 486. So the series can be written as I equals 1 times 12, 7i minus 5 in sigma notation, and the sum of the series is 486. All right, what is the sum of the series? I equals 1 to 13, 3i plus 2. Okay. So there's 13 numbers in the series. So I have 13 times the first number, so 3. I need to figure out when I is 1. So that equals 3 times 1 plus 2. So that's 3 plus 2, which is 5. And then when I is 13. So 3 times 13 plus 2. So that's 39 plus 2 equals 41. So I have S sub n equals 13 times 5 plus 41 by 2. 5 plus 41 is 46. So equals 1346 over 2 equals 598 divided by 2 equals 299. So this told me how many terms there were in the series. I looked at 1 and 13, and then I used my formula, S sub n equals n times a sub 1 plus a sub n over 2 to find out the sum, which is 299. Okay. How can you write the series 8 plus 13 plus 18 plus 43 using sigma notation? What is the sum? So I know that my last term in the sequence, so a sub n equals a sub 1 plus d times n minus 1. So let's see, a sub n equals 43, a sub 1 equals 8, and my d equals 13 minus 8 is 5. 18 minus 13 is 5. Okay, so d equals 5. So I had 5 each time. So I have 43 equals 8 plus 5 times n minus 1. So 43 minus 8 gives me 35 equals 5 times n minus 1 divided by 5 gives me 7 equals n minus 1. I add 1 to both sides, so n equals 8. Okay. So I go from 1 to 8. Okay, and I'm going to substitute that value back in. So I have 8 plus 5n minus 1, which gives me 8 plus 5n minus 5. So I have 5n plus 3. I'm going to rewrite using I, so 5i plus 3. Okay, so when I'm writing using sigma notation, so I'm actually going to come down here to this calculator. I'm going to go to functions, and that's going to give me my sum. Okay. So the bottom is going to be I equals 1. The top's going to be 8. And then the sum is 5i plus 3. I wanted to figure out the sum. So the sum was S sub n equals n times a sub 1 plus a sub n over 2, which equals 8 times 8 plus 43 divided by 2. So 8 plus 43 gives me 51. Times 8 equals 408 divided by 2 gives me 204. All right, example 6, use a finite arithmetic series. A pyramid of cans is on display at a supermarket. The top row has 1 can, the second row has 2 cans, the third row has 3 cans. If there are 10 rows of cans, how many total cans were used in the pyramid? Okay, so I find the arithmetic series when the common difference is 1. So find a sub 1 and a sub 10. A sub 1 is 1, a sub 10 is a sub 1 plus d times n minus 1. We're adding 1 each time, so 1 plus 1 times 10 minus 1, that gives me 9. 9 times 1 is 9, plus 1 is 10. Use the explicit formula for finding the sum of a series. So 10 times 1 plus 10 divided by 2 gives me 55. So there are 55 cans in the display. Okay, so a flight of stairs gets wider as it descends. The top stair is 15 bricks across, the second stair is 17, the third stair is 19. What is the total number of bricks used in all 16 stairs? Okay. So there's a difference of 2. So a sub 1 equals 15. I need to figure out what a sub 16 is. No, d equals 2. So I have a sub 16 equals a sub 1 plus b times n minus 1. So a sub 16 equals 15 plus 2 times 16 minus 1. So a sub 16 equals 15 plus 2 times 15, which is 30. 30, which equals 45. So a sub 16 is 45. Okay, so then I'm going to use a sub n equals n times a sub 1 plus a sub n. Equals n times a sub 1 plus a sub n. There we go. Okay. So n is 16, a sub n is 15 plus 45 divided by 2. 15 plus 45 is 60, so I have 16 times 60 divided by 2. 60 times 16 is 960, and then divided by 2 equals 480. So there are 480 bricks in the stairs. All right, concept summary, arithmetic sequence and series. In an arithmetic sequence, each term is equal to the previous term plus a constant d, the common difference. So the recursive formula, a sub n equals a sub 1 equals n equals 1, a sub n minus 1 plus d, where n is greater than 1. So for a sub 1 equals 1 and d equals 7, I have a sub 2 equals 1 plus 7 equals 8, so on. Okay. The explicit formula, which is probably what's most commonly used, and the arithmetic series. These two are the two most common ones. So the explicit formula, a sub n equals a sub 1 plus d times n minus 1. So if a sub 1 equals 90 and d equals negative 4, I have 90 plus 1 times negative 4 equals 86 for a sub 2, 82, and so on. The arithmetic sequence, basically, so I can find the sum of a set of numbers, the arithmetic sum of numbers. So S sub n equals n times a sub 1 plus a sub n over 2. I can also write it as a sum. So from 1 to 8, f5i minus 2. So I substitute each of these values in and I add them together. Or I can just use that formula. So I find the first one, the last one. There's 8 total in the series. I divide it by 2. So the first one was 3. The last one is 38. So 8 times 3 plus 38 divided by 2 equals 164. And that is the end of Unit 1, Lesson 4.